My name is Jacob Glenn. I'm the librarian for physics and astronomy at the Shapiro Science Library. And for the past several months, I've been working along with Alex and a bunch of other people in the College of Engineering to develop data management plan guidance for PIs who are writing proposals for the engineering directorate of NSF. So now that Alex has set the background, I wanted to maybe dig down into the nitty-gritty and talk about sort of a case study in developing this guidance and look at some specific examples of plans that we've seen. And I want to start by telling you where the effort came from, talk about some issues that we faced when we were putting together our guidance for PIs, how we addressed those issues, and some what I consider to be problems with the way we address those issues and how I wish we could have addressed them instead. And then I would like to say a little bit about the kind of institutional support that I think we would need in order to be able to do that. And then I'll end by talking about 2 or 3 promising projects that are going on at U of M that I think are going to take us in that direction. So the ad hoc working group in the College of Engineering was started a little bit over a year ago, and it was something that was originally got together by George Karanen, who's since stepped down as Associate Dean for Research and Grad Education. Alec Gallimore is his successor. And it really came out of the LS&A approach to dealing with the NSF data management requirement, which was basically to put it on the IT departments to vet these plans. So there was some discussion, I think, although I wasn't involved at this stage, but from what I've heard, there was some discussion between the Office of the Associate Dean for Research and Kane about whether this was the right approach for the College of Engineering. And as a result of this, a bunch of people came together to sort of address these issues and figure out what the best approach was for the college as a whole. And eventually, we decided that our main deliverable was going to be a template for PIs to provide guidance for the writing of these data management plans. So this is the current roster. Alec Gallimore, Paul Killey, of course, is the director of Kane. Linda Forsyth from COE Research Administration. Alex, Elizabeth Wagner, also from COE Research, and then myself. So the starting point for our discussions was really just the fact that Research Administration was getting lots and lots of questions about these new plans that no one knew how to write. And these were some of the most common questions that PIs were having. First of all, what data do I have to share? And this is not as easy a question to answer as we would like because it depends on who you're proposing to. The NSF does not have one definition of data. They sort of delegated that along with everything else to all the NSF directorates and divisions. So they all have slightly different definitions of what data are. How soon do I have to share? Can I wait till after I publish? That, again, has a wide variety of answers depending on who you're asking. For how long after the end of my grant must I continue to provide access? In the case of the engineering directorate, that's a minimum of 3 years, but again, it varies. Where can I store the data? That's the hard question, and we'll get back to that. If you're lucky, there's already a disciplinary data repository or an institutional data repository that you can put it in, but in many cases that's not true. I already published data in journals. Does that count? I'm a librarian, so I'm biased. My answer to this is no, not really. At least it shouldn't be the only place you're putting it because, for one thing, publishers go bankrupt, journals go under, and for another thing, there are a lot of people in the world who probably can't get to that data because the journal is behind a paywall and maybe you and your colleagues can access it, but to virtually everyone on the planet, it's completely inaccessible. And so it doesn't really answer what I think the NSF requirement is truly getting at, which is public availability of data. How do I budget for storing data after the grant is over? Another big, hairy question that I'm going to try and address in a little bit. I can't share my data because, where the because is usually followed by something having to do with privacy or confidentiality concerns and or IP concerns, which is more common in engineering. And of course, the engineering directorate makes lots of allowances for those sorts of things, but they do need to be addressed explicitly in the data management plan. And of course, the perennial favorite, question 8, can't you just give me some text I can copy and paste? And my answer to that one is a qualified no, but I'm going to spend most of my talk actually addressing the nature and extent of the qualification to that no, because I do think boilerplate can be very useful in the writing of data management plans if it is used appropriately. Unfortunately, it is more common for it to be used inappropriately. So our group initially was meeting once a month, and we've since been meeting a little bit less regularly since we've actually released our template, and we're working more now on implementing some of the things that are recommended in the template. So there are a lot of these NSF data management templates now. This is one from Purdue University, and I don't intend to denigrate it in any way by putting it up with the heading, "The Problem with Templates," but it does illustrate what I interpreted as some of the shortcomings of a lot of the templates that have been released. And I think this is a very good one, actually. It was the basis of the one that we ended up putting together for the College of Engineering. But as you can see, it's basically a list of questions, as most of them are. So under data access, are existing data repositories suitable for hosting your data sets and making them publicly available? If you don't have an existing repository, that is a disciplinary repository, what methods, infrastructure, systems, et cetera, will you use to share your data? Those are all really good questions that, that need to be asked, but unfortunately at the stage where researchers are preparing their data management plans, they often don't know the answers to these questions and don't know what would constitute a good answer or a bad answer. And so, you know, to the question, if you don't have an existing repository, what methods would you use? The answer is likely to be something like, well, I'll put it on CTools, or I'll burn it to DVDs and I will stick them in my desk drawer. These answers are more common than you might think, and they're not good answers. So what we wanted to do was really to create an opinionated template that would offer some actual opinions on how you should answer those questions instead of just telling you what questions need to be asked. And this is how we did it. This is a shot of my desk covered with data management plans. I was fortunate enough to work with some research administrators in the College of Engineering who provided me with reams and reams of these things, over 100 of them. I haven't actually counted them. And I sat down and I read them and I took a lot of notes. And I wanted to illustrate, not just provide boilerplate text, but illustrate what a good answer and a bad answer looked like by means of actual examples taken from actual plans. And so that's what the process looked like, and what I ended up doing was pulling out a lot of the most common problems that seem to be cropping up over and over again in these plans. And so here are some of them, and these may sound familiar to those of you who are in positions where you have to read these plans. Indifference to formats that are standardized. So standard formats are very important in data preservation. It's important to encourage people to avoid the use of proprietary data formats that rely on some specialized piece of software or hardware to read them. No understanding of metadata. That's not surprising to me as a librarian. No one knows what metadata is. Some people think it's computer code. Some people think it's a text file describing what's in their spreadsheet, which is better than nothing. Some people think it's a journal article describing their methods, which it's definitely not. So there was a little education that needed to happen in our guidance with respect to what metadata actually is. Lack of distinction between backup and archival. So you know, backing up your data to the network attached storage and leaving it in the dark for 3 years is not data sharing, but some people think it is. Lack of awareness of licensing. I'm very sympathetic on this one. I'm not a lawyer, and neither are most researchers. And there are a lot of legal intricacies involved in the licensing and sharing of data, as Alex discussed. But we found that since most people don't have the patience to delve into those legal intricacies, it was desirable to provide a default set of licenses that could be applied to cover most cases in which there was no monetary interest in the research products, so that we could just point people to a license and say, use this. Confusing journal publication with data sharing, that's very common, and unjustified and unnecessary restrictions on data availability, saying, I will make my data available upon request. is okay if you justify that, but it needs to be justified because, again, the NSF mandate gets at public availability of data in an unmediated way. There are lots of reasons why you might need to limit that, but you need to address those reasons in the plan. And then, of course, failing to address all parts of the DMP, also very common. So this is a screenshot of the template, and it's kind of hard to see. I'll show a closer one in a minute. Basically, this is just the document design. It's a little bit different from the list of questions format. It's got 2 columns, and you can see that the left column is very similar to the list of questions format. It starts with a reference to NSF documentation with a link to the full documentation. There's a little summary for each section. Then there's a question, but then after the question, we have examples. The examples are color-coded. I've been told that people with red-green color blindness are going to have a hard time with this, so I might have to change the colors. But basically, green is good and red is bad. Initially, I was planning to include one good and one positive, I should say, a positive and a negative example for every question. But since a lot of these questions have multiple facets, it turned out that we needed to include multiple examples for most questions. And then in the right column, there is a heading, which you probably can't read, called Resources and Commentary. And basically, that's just a column for links to additional documentation as well as commentary on both the questions and the examples. And the commentary on the examples turned out to be very important. I didn't initially plan on putting that in because I figured that it would be self-evident why this was a good example or a bad example, and it turned out it wasn't quite as evident as I thought it would. So there's a lot of attempts to explicate that a little bit. So the strategy is basically draw the outline of a good answer and a bad answer without really providing a single standardized piece of text that you can put in there. And this is just one example from the data archiving section of the template. So the question is, which archive, repository, database have you identified as the best place to deposit your data? That should look familiar. That's basically an adaptation of the question from the Purdue template. But then over here on the right, we've got some links to lists of data repositories and then the examples. So the good example, upon finalization, the calving histories we derived from satellite data will be submitted to the National Snow and Ice Data Center. That's astonishingly rare to see someone actually identifying the correct data repository for their stuff in their plan. So this is a rare gem that we wanted to include. And then below that, it's actually from the same proposal. The infrastructure provided by NSDIC is not yet either designed or suitable for distribution of software. So we're going to release and distribute GPL versions of our software as tarballs from our institutional website. That's included as a positive example, and it illustrates a limitation of this approach in that I didn't really have space to address some of the negative aspects of that. I mean, if you're going to be distributing your software, it's probably not the best thing to host it from your institutional website, but doing it is good. So we wanted to illustrate that this is something that should be addressed in the plan, but I just didn't have space to look at some of the less favorable aspects of it. And then the negative example below it, at the end of the project, original laboratory notebooks will be secured by the PI in his campus office. Computer files will be stored in the form of hard drives as well as on ctools. That's a more common sort of answer that you see to this question. So now I want to talk a little bit about boilerplate. And this is one thing that PIs always asked for. It was one of the most commonly asked questions going in, as you remember. And I think this is a totally reasonable request. In fact, I say the less of the data management plan the PI has to write, the better. And the reason for this is because if we don't give them boilerplate, they're going to come up with their own. And I've read enough of these things now to know that there is lots of recycling of text that is going on. So PI writes one data management plan. In every subsequent plan, they're just going to copy and paste most of it in there and maybe make some little adjustments for the particular project. And that's great if their first plan was really good. But if it wasn't really good, then their subsequent plans are not going to be very good either. And this phenomenon is not limited to excellent data management plans, in my experience. So I think it's in everyone's best interest to provide effective boilerplate to the extent that we're able to do so. What we gave them instead was a 30-page document full of examples and links to documentation. This is a really big, scary document. It's not something you're going to read the night before your proposal is due and write the best data management plan ever. It could be a big deterrent, I think, in the sense that if you're on a deadline, which people frequently are, you might just decide to email your colleague and say, hey, do you have a plan that I could use? Which might not be the best thing. So this is a problem. Why did we do things that way? Well, in part because there's a challenge inherent to writing guidance for the entire college. There's such a huge diversity of research that's going on, even in one college, that it's really hard to provide boilerplate that works for everyone. But also, I think there is a huge potential for misuse of boilerplate, which we're going to look at here. So does anyone recognize this piece of text? Okay, Anne does. Someone else does. Yeah, this is from the ICPSR framework for creating a data management plan. And this is a great piece of boilerplate to use if you happen to be collecting survey data for your research project. In fact, I would say the ICPSR framework is an excellent resource for anyone who is creating data that is of the sort that would normally be curated by ICPSR. Problem is, this wasn't taken from a proposal that was collecting survey data or indeed any kind of data that could be personally identifiable. This proposal was for the collection of ice cores in Antarctica. Now, what does that have to do with personally identifiable information? Nothing. So why did they include it? Well, I suspect that they just didn't know what to put there, so they went online and they found something that they could put there. So this is a big problem. If I were reviewing this proposal, that would be a red flag to me that says this person didn't take the DMP seriously. At least that is the most charitable interpretation I can think of. So that's an example of how boilerplate can be misused. Let's see some really good uses of boilerplate. These are all taken from the same proposal. It's from a researcher at the U of M Biological Station. As you may know, the UMBS has been putting a lot of effort into developing their data management infrastructure, including software. They have their own repository based on Drupal. They've got a data manager, that's Kyle Kweiser. They've got a lot of standard policy that they've developed. And they can do this basically because they're very centralized and the research is done at one location, so they can maintain pretty tight control over how it's managed. So you get this great data management plan that's got stuff like, the UMBS Research Gateway will be used for providing long-term public access to the data sets. Policies provided by UMBS will be used to guide metadata and data sharing. Per the UMBS policy, all data sets will be deposited within a year of completion, and then this actually ended with, I think, a link to the full policy. I will work closely with the UMBS Information Manager to ensure metadata completion and quality assurance of data files. The whole proposal basically reads like this. I think it's pretty much all boilerplate. I would have to check with Kyle on that. But it's great. It's one of the best plans I've ever read. So you can use boilerplate effectively if the services are there to support it. The challenge is, how do you do this for a research community of the size and diversity of the whole university, or even for a medium-sized department when there's not that sort of tight control that they have at a place like the biostation? And that's a really good question that I'm going to try to address here in a little bit. I want to show another good example that kind of hints at where I'm going with this. This is from the University of Virginia Library, which has a division called the Scientific Data Consulting Group. And they are putting together data management templates for every NSF directorate and division that has issued guidance, which I think is about a dozen of them by now. And every single one of those templates has the same piece of boilerplate in the archiving section. As advised by University of Virginia library staff members, I plan on depositing my research data in the UVA Institutional Repository, Libra. I will submit the necessary metadata, etc. In accordance with the university policy, the data will be preserved for a minimum of 5 years. However, the current preservation plan is to preserve it indefinitely. So UVA is pouring a lot of resources into the development of this institutional data repository. And because they're doing that, they can provide this standard boilerplate that ties into their standard service, and everyone can use it. And it is always appropriate, pretty much. There are some issues here. I'm made very nervous by this line about, I will provide the necessary metadata. When you have researchers taking responsibility for providing the metadata, there's a question of who's going to make sure that that happens. And so I think there would need to be, in addition to a standard service like a data repository, there would need to be services for people who are using that to make sure that they use it correctly. But anyway, this sort of hints at a few goals that we could aim at in the interest of enabling effective boilerplate for data management plans. And I'm aware at this point that I'm putting the cart entirely before the horse, but since I got into this whole thing about data management from the perspective of creating guidance for people writing data management plans, that's sort of how I look at it. Of course, data management done well is a worthy goal in its own right. So I'm going to call these the 3 pillars of effective boilerplate. And the first one is standardized services, as illustrated by the UVA example. By services, I'm referring, first of all, to IT services that are the infrastructure that underlies data management, but also to the services that are directly aimed at users. Okay, if I'm down to 1 minute, then I'm going to have to skip some stuff. Sorry about this. Second pillar, just local norms, and here I'm talking specifically about policy, standardized institutional policies for things like data retention periods, access and sharing, licensing. Those things, obviously, there needs to be a lot of wiggle room, but there, I think, is potential to provide good defaults on a university level. And then the third pillar, which is really sort of a meta pillar, is just organizing for research data management. And this just means having the right connections within the organization as a whole to support the coordination of all the services that it takes to be able to do data management really effectively. And this is an example from Cornell. It's not intended to be prescriptive. It's just an example of what a lot of universities are doing to reorganize themselves around support for data management. And building these at I'm going to skip over these really quick because I'm out of time, and you all probably know about most of these. First of all, there's NextGen. I've been privileged to participate in a little bit in one of the groups, the Data Storage Strategy Working Group, which is working on the storage component, and that includes goals for things like information lifecycle management and long-term archiving, which I think will go a long way towards providing the sort of standardized services that we need backing up the creation of these plans. There's the LSA data classification tool. This is a screenshot of the paper version. This is currently being turned into a web-based decision tree that's going to help researchers classify their data to inform the decisions that are made by the IT managers when they're provisioning services to use for managing that data. DMP tool is a collaborative project. ICPSR is a partner on that. And I think this has the potential to become a useful tool for collaboration among all the different units that need to have a hand in provisioning services to support data management. And now I'm going to turn it over to Amy.